Hello and welcome. This is Bijan Hoshiar. After completing this lesson, you'll have an understanding of importance and functionality of PKI and the related technologies to PKI. Components of network security include device hardening, using AAA service, configuring access control lists, installing and configuring firewall, using intrusion prevention system, and installing anti-malware. Components of communication security include confidentiality, integrity, authentication, and non-repudiation. Integrity guarantees that no one has intercepted and changed the message while in transmission. This is performed by hashing. Authentication guarantees that the message is not a forgery and comes from whom it states. Non-repudiation guarantees that the sender cannot repudiate or refuse the validity of the message sent. Confidentiality guarantees that if the message is captured, it cannot be deciphered. This is achieved by encrypting the message before sending it. Encryption can be performed in two ways: symmetric encryption and asymmetric encryption. In symmetric encryption, the same key is being used by two communicating devices to encrypt by the sender and decrypt by the receiver. The protocols that can be used can be DES and 3DES, in addition to AES. The keys are going to be generated by performing a complex calculation by using Diffie-Hellman on both devices. Therefore, both communicating devices have the same key. They can use it both for encrypting and decrypting the messages that they exchange. Using 3DES encryption. If Alice wants to send an encrypted message using 3DES, Alice is going to first encrypt the plain text message using key 1. The encrypted message then will be decrypted with a different key. We call it key 2. After that, the decrypted message will be again encrypted with a separate key called key 3, and it will be sent to recipient. In this example, Bob has received a ciphertext from Alice. Alice used 3 keys to encrypt, decrypt, and encrypt again. We call those keys key 1, key 2, and key 3. Bob is going to perform the reverse process in here by first using key 3 to decrypt, then using key 2 to encrypt, and then using key 1 to decrypt, to see the plain text that was generated by sender, in this case Alice. In asymmetric encryption, 2 keys are being used: public key to encrypt and private key to decrypt. For example, if Alice wants to send an encrypted message to Bob, Alice first asks Bob to send her his public key. Then Alice is going to use the public key sent by Bob to encrypt the message and then send the message to Bob. That encrypted message can only be decrypted by the private key that only Bob has and nobody else has. The protocol that can be used could be RSA. The keys are going to be issued by CA. In addition to asymmetric and symmetric encryptions, digital signatures and hashes also use keys. Digital signatures provide authenticity, integrity, and non-repudiation. Digital signatures ensure secure communications between websites and that the downloads are legitimate. Digital certificates are a mathematical technique. Public key infrastructure consists of specification systems and tools. It is responsible to create, manage, distribute, use, store, and in some cases, revoke digital certificates. PKI elements include Certificate of Authority, CA, which is the party that issues certificate. It will store those certificates on its database called certificate database, and a copy of it is going to be sent to the individual or organization that requests the certificate. That individual or organization will store the certificate, for example, on a computer, which is referred to as certificate store. So the elements include CA, database, certificates, and certificate store. PKI topologies include single root, cross-certificate, hierarchical, and hybrid. In a single root topology, there is only one CA called root CA. It's simple to use, however difficult to scale. It has centralized administration and single point of failure. In a cross-certificate topology, there are more than one CA. In this example, I'm showing two CAs, CA1 and CA2. Those two CAs trust each other. They establish a trust relationship. Therefore, the client of one CA can trust the client of the other CA and exchange communication safely. In a hierarchical topology, there is a root CA, but that root CA may have some subordinate CAs, and those CAs are going to issue certificates to the clients. An example of hybrid topology is when hierarchical and cross-certificate topologies are combined together, as the topology on the right-hand side of the screen shows. Thank you for watching. If you liked the video and you found it informative, please don't forget to recommend it to others who may be interested. Thank you.